All right, take 3, problem number 4. I'm having a little trouble here. So we have a region here with this function on top and y equals 3 on bottom. First thing I need to do is figure out where these meet. So I set them equal to each other and I get 6 equals 3 plus 3x squared. I subtract 3, divide by 3, and end up getting x equals plus or minus 1. So do the integral from -1 to 1. So at first I thought, I can't integrate this because natural log of 1 plus x squared would give me a 2x chain rule. And then I remembered these 3, so the derivative of arc sine is 1 over square root of 1 minus x squared. Arc cosine is -1 over square root of 1 minus x squared, and arc tangent is 1 over 1 plus x squared. Say hi to the family. There's Jage. He's got a sad face on today. Crystal. Carly. So that arctangent looks good here. So I'm going to go arctan of x, which would give me 1 over 1 plus x squared. So I'm going to put a 6 in front of it, minus 3x. I'm going to evaluate that from -1 to 1. So I'm going to put a 1 in. So I'm going to do 6 arctan of 1 minus 3. And then I'm going to do 6 arctan of -1 plus 3. And arctan of 1 is the first place where tangent is equal to 1, which would be at pi over 4. And then arctan of -1 is the first time tangent is equal to -1, which would be negative pi over 4. And then I got this plus 3. So I got the -3, and the -3 gives me -6. This is 3 pi over 2. That's 3 more pi over 2 that I'm going to add because of those negatives. So I'll get 6 pi over 2, which is 3 pi. So I get 3 pi minus 6. Next one, I'm going to take the same region that I drew and I'm going to rotate it around here. This creates a washer. So the 3 things I need for a washer is h, which is dx. I need the radius of the outside, which would be this minus this, so 7 minus 3 gives me 4. And then I would need the radius of the inside, which would be 7 minus this function. Okay, so if I'm going to do an integral, I'm going to factor that pi out. I'm going to go -1 to 1 of 4 squared, so I'll just call that 16, minus this 7 minus, I'm going to call that f of x, since I don't have to write all that stuff, dx, since I'm not evaluating, and that'd be my answer there. The last one says, let h be the vertical distance between some point x, f of x, and the line y equals 3. And then it says around x equals 2. So if I'm looking in this area here, so that vertical distance would be right there. So the vertical distance would be 3 minus f of x, which I've got here. So then h prime of x would be would be just minus f prime of x. And f of x is 1 or 6 over 1 plus x squared. So if I'm going to take the derivative of that, I'm going to think of it as 6 times 1 plus x squared to the -1. So I get -6, 1 plus x squared to the -2 times 2x. So right here I get minus, and then I have -12x over this guy squared. So 1 plus x squared squared. So if I plug a 2 into here, then I get that's not part of this. So that's a positive 24, and this is a positive 25. So it's growing at 24/25, which makes sense as I'm moving right here. Makes sense that this distance is increasing at that point. So if I messed up my sign, maybe I would catch that. All right, guys, thanks. I'll be back for number 5 soon.